Yes, students, again welcome to the online video session. Let's learn something new today. In the previous video, we have went through about different problems on basic problems and also problems on elastic constants. So now it's a time to study about cylinders. That is thin cylinders. This is a concept of thin cylinders. Basically, we come across two kinds of cylinders. That is one thin cylinder and thick cylinder. Thin cylinder and thick cylinder. So let us understand the definition of thin cylinder. Thin cylinder, what the definition says, it is a cylinder in which thickness of a cylinder is less than d by 10 of a cylinder. That is 1/10 of the diameter. If thickness is less than 1/10 of the diameter of cylinder, then such cylinders are called as a thin cylinders. If it is greater, then it is called as a thick cylinder. It is a cylinder in which thickness of a cylinder is more than d by 10 of a cylinder or 1 by 10th of diameter of a cylinder. This is the definition. In these kinds of cylinders, normally two types of stresses are induced. One is hoop stress or circumferential stress, longitudinal stress. One is hoop stress and longitudinal stress. Let us understand one by one. Hoop stress. Hoop stress is defined as it is a stress induced along the circumference of the cylinder. Hoop stress is nothing but it is a stress induced along the circumference of the cylinder. That is why it has got another name, circumferential stress. So I'll explain you with an example. This is a cylinder, students. This is a cylinder. This is a cylinder. Just I have sectioned the cylinder so that I have got this circumference. And stress acting along the circumference, this is arrow marks. These arrow marks are called as a hoop stress. So here the stresses are acting along the circumference of the cylinder. This is very simple. So what will be the formula for hoop stress? FH. F is nothing but stress. As you know, H is nothing but hoop stress. FH equals to PD by 2T. Let's understand different parameters. FH is nothing but hoop stress in Newton per mm square. And a P is nothing but pressure in a Newton per mm square. D is a diameter in mm. Thickness, T is thickness in mm. This is the formula for hoop stress. Just remember FH equals to PD by 2T. Very important formula. Now let's study about longitudinal stresses. So it is a stress induced along the length of the cylinder. This is a stress that is induced along the length of the cylinder. Whereas in case of hoop stress, it is induced along the circumference. Whereas in case of longitudinal stress, it is induced along the length. The formula is FL equals to PD by 4T. Let us see the diagram. See students, this is the cylinder and this is a length. This is a lengthwise. See, this is a lengthwise. So along the length, the force is acting, the stress is acting. So that is called as a longitudinal stress. The formula becomes FL equals to PD by 4T. That formula is FH equals to PD by 2T. This is FL equals to PD by 4T. So always hoop stress will be twice the longitudinal stress. Same, FL is nothing but longitudinal stress, P is nothing but pressure, D is a diameter in mm, T is thickness in Newton. T is thickness in mm, sorry. This I have written it in terms of, this is not the unit for thickness. Unit for thickness is mm, okay. So this is a unit. Okay, done. So now let us study different assumptions made in thin cylinder. Assumptions made in thin cylinder. First, what is the first assumption? The material of a cylinder is homogeneous and isotropic. So homogeneous is nothing but the properties all same throughout the body. The properties are same. Isotropic means they are same along one direction. So the material of the cylinder is homogeneous and isotropic. Next is material of cylinder obeys Hooke's law. Hooke's law is nothing but within elastic limit, stress is directly proportional to strain. So next is stress is uniformly distributed. See, if I apply a load here, if I apply a pressure here, due to pressure, the stress is induced. So that stress is uniformly distributed throughout the cylinder, not to, it is concentrated at only one point. It is distributed throughout the cylinder. Cylinder is considered to be thin walled because we are dealing with thin cylinders, so we consider it should be a thin walled. So next, plane sections of in remained plane even after application of internal pressure. So students, if I apply a pressure, there may be certain changes in shape, but assumption is even though if we have if we apply a pressure, the plane remains plane. It doesn't change its shape. This is the assumptions that are made in thin cylinders. And let us see the formula that are used. Only these two formulas are used. With the help of these two formulas, we will try to solve different problems. What is this? This is a formula for hoop stress. Fh equals to Pd by 2t eta L. This is the eta L, students. Eta L. So this is eta L. This is eta is nothing but efficiency. Eta is nothing but efficiency. L is nothing but longitudinal. I mean longitudinal efficiency. Whereas in case of this one, longitudinal stress, PFL equals to PD by 4T eta H. Eta is nothing but efficiency. Eta H is nothing but circumferential efficiency or hoop efficiency. Students, very simple. If I am writing the formula for hoop H, then I should use alternate one L here. If I'm writing for L longitudinal, then I should use H here. So that is a trick you need to just remember. Okay, now let's move on to the next slide. Directly, let's move on to the problems. This is all about the theory that this content has. Now let's move on to the problems. So let's see the problems. These are problems on thin cylinders. What's the problem says? A vertical pipe, vertical thin pipe, 4.8 meter in diameter and 30 mm high. If allowable working stress is 120 Newton per mm square, what is the required wall thickness of the pipe? Assume the pipe is filled with water of specific weight of 10 kilonewton per meter cube. Okay, this is a question. So let's solve the question by writing the given values. So first given value is the diameter of the pipe is 4.8 meter and 30 mm high. High is nothing but, 1 second students. Yes. So he has given the diameter is 4.8 meter. So immediately I am going for the unit conversions because it is in meter. So I am going for the unit conversion. The unit conversion becomes 4.8 into 1000 mm. So that is why D equals to 4800 mm. This is immediately I am doing the unit conversion. Since we came across from the previous problems, we came across that unit conversion is very important wherever it is necessary. So I am writing the data and immediately I am going for the unit conversion. Okay, so it will not make any problem for you. Next, height is equals to 30 mm, h is equals to 30 meter. So yeah, he has given 30 meter, h is 30 meter. Again I need to go for the unit conversion. That is h is equals to 30 into 1000 mm. In place of meter I'll put 1000 mm. The formula becomes, so h equals to 30,000 mm. This is mm, students. So this is mm. Yes, the formula becomes 30,000 mm. So next, F is equals to 120 Newton per mm square, and it doesn't need any unit conversions. Okay. Then what is the required wall thickness of the pipe? He is asking us to find the thickness of the pipe. T is question mark. And assume the pipe is filled with water of specific weight. Specific weight is capital W. I'll take it as capital W is equals to 10 kilonewton per meter cube. So we need to go for the unit conversion for W. This is what the unit conversion is. So I'll write 10 as it is. In place of kilo, I'll write 10 power 3. And here there is a meter cube. So at the bottom below, I'll write 1000 cube. Why I'm writing in the denominator? Because meter is in denominator. See there is a slash. So meter is in denominator. So I'll write 1000 cube in denominator. In place of meter, I'll put 1000. The meter has got cube. So I'll put cube for 1000. Okay. Okay, this is the unit conversion of weight. On calculation, I'll get specific weight is equals to 1 into 10 power 5 Newton per meter cube. This is the value for specific weight. Okay, done. So now let's solving the problem. First, we need to find the pressure. From the specific weight, let us find the value of P. We know the value of formula for P is P equals to W into H. So we know the value of W and also we know the value of H. So we can find the value of P. So on substitution, I'll get this step, and on calculation, I'll get the value of P equals to 0.3 Newton per mm square. This is the value for pressure. Once I get the pressure, now it's a time to find diameter, thickness. In order to find thickness, we have only two formulas, that is FH and FL. I am supposed to use that formula. So in this case, I'll do two cases, because he has not mentioned whether it is a hoop stress or longitudinal stress. Okay, he has given only the stress. If he has given stress, what I should take? Whether should I take it as a hoop stress or should I take it as a longitudinal stress? So what I should do is I should take it as a both. I should assume it as a both. So that is why I'll do case 1 and case 2. In case 1, I will take this, I will consider this stress as a hoop stress. This is the case 1. So I will consider this stress as hoop stress. So FH equals to F. Then the value of FH will become 120 Newton per mm square. Students understood? I will do two cases. In case 1, I will assume this as a, in case 1, I'll assume this stress as hoop stress. In case 2, I will assume this stress as a longitudinal stress. Okay, so right now we got FH equals to 120 mm. I'll take the formula for FH. FH equals to PD by 2T eta L, and here eta L is not given. If it is not given, just I'll omit. I'll not use that formula. I'll not use that term. Just I'll substitute the values. So F is equals to 120, P is nothing but 0.3, D is nothing but 4800, 2 as it is into thickness right as it is. In place of eta L is not given. If it is not given, just don't put a value for that. Just you leave it. Just omit that eta L. If he has given only the efficiency, if he has given efficiency, only then you are supposed to use this term. If not, just you leave it that term. On calculation, on simplification, I'll put 120 as it is, and I'll multiply 0.3 into 4800. I'll get 1440 divided by 2 into T as it is. So now it's time for cross multiplication. 120 into 2 into T equals to 1440, and I'll multiply 120 into T into 2. I'll get 240 into T, 1440. Now from this, T equals to 1440 divided by 240. Okay, so right now I'll get the value of T is 6 mm. This is the value for T by using FH as F. That is case 1. Now I'll go with case 2. Case 2 is equals to FL equals to F, longitudinal as equals to stress. So FL is equals to 120 Newton per mm square. Then I'll use a formula for FL. Once again, here eta L is not known, so I'll go with only the remaining terms. Just I'll omit eta L on substitution. This is a formula with simple cross multiplication. I'll get 120 is equals to 1440 divided by 4 into T. On cross multiplication, I'll get the value of T as 3 mm. Right now, I have two values. One is 6 mm and 3 mm. So I should take the bigger thickness, that is a 6 mm. This is a 6 mm is the value for thickness. So out of two, I should choose the bigger value, that is 6 mm for thickness. This is the answer for this question. It's very simple question, students, because we have only two formulas, just simplification, just substitution, simplification, that's it. Okay, now let's move on to the next set of next question. So what the next question says is, so a cylinder of 15 mm thick has to withstand a maximum internal pressure of 1.5 Newton per mm square if the limit tensile stress is 300 Newton per mm square, factor of safety is 3, and the joint efficiency is 80%. Find the diameter. Students, in this question, he has mentioned efficiency. So in the previous question, he has not given efficiency. So that is why we omitted eta L and eta H. But in this case, he has given the efficiency. Okay, let's write down the values. T is equals to 15 mm. A cylinder of 15 mm thick is nothing but T is equals to 15 mm, has to withstand a maximum internal pressure P equals to 1.5 Newton per mm square. If a limit tensile stress, a limit is nothing but maximum. Students, it's very important. He has not given the tensile stress. He has given limit tensile stress. That is nothing but ultimate. That is nothing but maximum tensile stress. That's why I have written FU. F is nothing but stress. FU is nothing but ultimate stress. 300 Newton per mm square, then FOS 3, and efficiency eta is equals to 80%. Students, one thing, he has given only the efficiency. He has not mentioned particularly whether it is a longitudinal efficiency or circumferential efficiency. He has given only efficiency, so I'll take eta. Suppose if he has given circumferential efficiency, then I would have taken eta H. If he has given longitudinal efficiency, then I would have taken eta L. Right now, in this case, he has given only efficiency. He has mentioned only the name efficiency. That is why I have taken eta. Okay. Okay, done. So next, first I'll try to calculate F, because I know the ultimate stress, but I require stress. Okay. Out of factor of safety, I will find out the value of stress. Factor of safety is equal to fu by f. Just as cross substitute the values. 3 is equal to 300 divided by f. On cross multiplication, I'll get the value of f. That is 100 Newton per mm square. Students, once I get the f value, again I am supposed to do the two cases. That is case one and case two. In case one, I will take fh equals to f. Then I'll write the formula for fh equals to 100 Newton per mm square. Then fh equals to pd by 2t into eta L. So here, students, since as said, he has given only the efficiency, not particular efficiency. So that is why what I'll do is for both the cases, longitudinal efficiency and even for circumferential efficiency, I will use the same value. I'll use 0.8. So this is on substitution. On cross multiplication, I'll get the value for diameter, that is 160 mm. So I'll explain you the way I got the values. So this is a substitution. This is just a substitution. What I'll do is, so I'll calculate the denominator value. I'll calculate denominator value. So I'll put 100 as it is, 100 as it is, 1.5 as it is, into as it is, diameter as it is, and I will multiply 2 into 15 into 0.8. That's why I'll get 24. Next, in the next step, I will cross multiply and I will bring this 24 to left side. So that's why I'll get 100 into 24 is equals to 1.5 into D. This is 1.5, students. So this is a 1.5. No. Yes, this is a 1.5. Okay, done. It's a 1. Yes, it's a 1.5, students. Since pressure is 1.5. Okay, on cross multiplication, 100 into 24, this is a value, and 1.5 into D. On cross multiplication, I'll get the final answer as 160 mm. 160 mm. Students, instead of taking 1.5, I have taken 15 here. So suppose if you take a 15, so I'll get this value 160, and you just check by substituting 1.5. Okay, so instead of taking 1.5, I have taken 15 with the confusion. So what you do is, just to understand the concept, then you try to replace 15 with 1.5, then you calculate your answer. So you will get a bit different answer. Okay, not a problem. So this is a diameter. So now let's move to the case 2. In case 2, I will take FL as F. So longitudinal stress as this one. With the formula on substitution and same cross multiplication as I've explained the previous for case 1. So finally, I'll get the value of D is 320 mm. Even in this case also, I have taken 15 instead of 1.5. So this is wrong. I should take 1.5. I should take 1.5, but with some mistake, with some confusion, I am taken it as a 15 with the oversight. So what you do is you take this formula, take this question, and you try by substituting it 1.5, and you will get some answer. Students, since I got two values for diameter, then I should take so diameter as a lower value. For thickness, I should take a bigger value. For diameter, I should take lower value. For thickness, I should take bigger value, and for diameter, I should take lower value. This is what I should do. So in case of thickness, always you take a bigger value. So in the previous case, we got a thickness for two values, that is 3 mm and 6 mm. So in that case, I have taken 6 mm as a answer. I have chosen 6 mm as an answer. But in this case, I have got two values. One is 160 and one more is 320. Out of 160 and 320, I should choose the lower value, that is 160 mm. Students, that's it. This is the solution for your question. I hope you have understood this question, and with the help of this question, these two questions, you just practice other number of other questions, some bit difficult with other values. You can just go on changing the values so that you can solve for a number of problems. So this is a concept. Yeah, it may be any problem, students. You apply this concept, then definitely, even it may be a very complicated problem, you will get the solution. So this is all about the problems on cylinders.